what do we got in the inbox today for myths?
Well, we actually have a really good one. This is one that comes up a lot. The scientist is wondering how carbon load on a column relates to the overall retentivity that you can expect to see with a column. And that's a really difficult question to answer. So I think that this is one we should definitely look at.
Cool. I love looking at retention myths because they're so easy to remember. Get
Doug,
it?
what do you think we should do for this?
So since this myth obviously involves carbon load, we can look at some of the columns we may have looked at before that have the different carbon load values, and we can run those columns under the same set of conditions and just take a look at the overall retentivity and see if it pans out. See if we can find some sort of correlation between carbon load and retention.
That sounds really good. Why don't we get those columns and then take it to the lab?
Sounds great.
Okay.
All right, Kim, that was a pretty straightforward set of experiments. We just ran the same columns under the same conditions,
That's probably the most boring experiment I've ever done in my life.
but we needed the data, so we had to do it.
Yeah.
So getting back to looking at the results from percent carbon and overall retentivity, we ran a bunch of columns, able to track the overall retentivity of those columns. How does the data look?
Okay, let's take a look. So when we look at the overall retentivity of all these different columns, we can see that there's really no correlation at all between the percent carbon and the overall retention. The highest retentive phase that we see out of the columns we tested had a middle of the road percent carbon of only 13%. And that was, again, the highest retentive phase. So you'll also notice that the lowest retentive column, the percent carbon value is only 5%, but this phase is not 3 times less than that with a carbon load of 15%. So there's really no direct correlation we can draw between retentivity and the percent carbon.
Yeah, I see that, Kim. It's easy to notice.
So since there's no correlation, what's really important here? What has the effect?
Yeah, Kim, that's a great question. So what really drives retention is what's known as the phase ratio of the base particle. And what that is really just a ratio of the pore volume and the overall surface area in its most simplest forms. So here we ran a couple columns just as an example of 2 columns that have the same pore volume and different surface areas, but they had the same overall bonded phase coverage or percent carbon load. And as you can see from the chromatography, when you look at the HSSC18 compared to the BEHC18, you'll see that the HSSC18 has much higher retention based on the fact that that phase ratio of that base particle is much higher.
So it's really great to have all of this data showing the comparison between all these different columns with all their different percent carbon values, because that's one of those questions that comes up pretty frequently from a lot of scientists just like this.
Yeah, Kim, there's so many other factors in this chromatography and the base particles that dictate the overall retentivity of the phase. Like you said, we talked about phase ratio, pore volume, surface area. If you're not familiar with all this stuff, it's kind of confusing.
It is. So when you're trying to choose a column, if you're looking at USP designations, right, like the L1,
Yep.
or if you're looking at percent carbon, it really just doesn't tell the whole story.
Doesn't tell the whole story. That's right.
All right, so I think we need to email this customer and let him know that the percent carbon load doesn't really tell him how retentive the column's actually going to be.
Yeah, based on percent carbon alone, Kim, this myth is busted. It's
think it
really
is.
hard to track or to correlate overall retentivity with just the carbon. It's just, there's other things in play. Like I said, pore volume, surface area, they're all important too.
If you'd like your question to be answered on a future episode, please feel free to email us at trustyourscience@waters.com.